High-fructose corn syrup did not begin as a soda villain. It began as a science breakthrough in the 1950s inside an American corn company. The title says the man who invented it, but the stronger historical answer starts with two researchers, Richard O. Marshall and Earl R. Kooi. Marshall and Kooi worked at Corn Products Refining Company, and in 1957 they reported a way to make corn syrup much sweeter. Their key idea used an enzyme later called glucose isomerase to convert glucose from corn into fructose, which is a sweeter sugar. That 1957 report was the conceptual birth of high-fructose corn syrup, even though the first version was not yet ready for supermarket domination. So the real story is bigger than one lone genius. It starts with two inventors and then grows through engineers, factories, and food policy. That matters because invention and transformation are not the same step. A lab discovery can exist for years before it changes daily life. In the 1950s, Marshall and Kooi were solving a chemistry problem, not trying to redesign soda fountains, bread aisles, and ketchup bottles. Regular corn syrup was mostly glucose, and glucose is less sweet than table sugar, which made plain corn syrup less useful as a sugar replacement. If part of that glucose could be rearranged into fructose, the sweetness would rise, and corn could become a more powerful industrial sweetener. That was exciting in the United States because corn was abundant, while cane sugar and beet sugar could be expensive and hard to predict. Sugar prices could change with weather, world trade, and politics, but American corn already existed in huge amounts inside the national farm economy. Marshall and Kooi published their breakthrough in 1957, and a patent followed in 1960, which shows the idea had real commercial promise. But promise was not enough. The early method was still too expensive and too inefficient to flood the American food system. This is where the story gets more interesting, because many famous inventions have two different lives, and high-fructose corn syrup followed that pattern. The first life happens in the lab, where someone proves a new idea can work. The second life happens in factories that scale it. Marshall and Kooi solved the first part by proving that glucose from corn could be turned into fructose through enzyme action. The second part needed better process engineering, and during the 1960s, Japanese researchers and engineers played a major role in that improvement. Their work made the enzyme technology better and helped large-scale production become commercially viable instead of staying an expensive scientific curiosity. So if someone asks who invented high-fructose corn syrup, the careful answer is Marshall and Kooi opened the door in 1957. If someone asks who turned it into a giant industrial force, the answer includes later innovators, especially Japanese process engineers in the 1960s. That fuller chain matters because the food system changed only after the chemistry became cheap enough, efficient enough, and reliable enough for mass manufacturing. By the late 1960s and early 1970s, high-fructose corn syrup had become a practical commercial sweetener instead of a lab concept. Different versions appeared, and their names mostly describe how much fructose they contain in the syrup mixture. HFCS 42 contains about 42% fructose and about 58% glucose, and it became common in many processed foods. HFCS 55 contains about 55% fructose and about 42% glucose, and it became especially important in soft drinks. There was also HFCS 90, a much more concentrated form used mainly as an intermediate blend stock rather than a common supermarket ingredient. Those numbers matter because many people think high-fructose corn syrup is almost pure fructose, but that is not what the chemistry shows. HFCS 55 is not pure fructose at all. It is mostly a mix of fructose and glucose plus a small remainder of higher sugars and water. Table sugar, also called sucrose, is roughly half glucose and half fructose, but in sucrose the two sugars are chemically bonded together. HFCS contains a similar pair of sugars, yet they are not bonded together in the same way as ordinary table sugar. That compositional similarity became a huge part of later nutrition debates, because critics and defenders argued over how different the sweeteners really were. Many nutrition scientists say HFCS and sucrose are broadly similar calorie for calorie, which means blaming one alone can oversimplify the science. Critics answer with concerns about fructose handling in the liver and about how cheap liquid sweeteners can encourage people to consume too much. That scientific argument became famous later, but first, high-fructose corn syrup had to win an economic battle inside American manufacturing. The big turning point came in the 1970s and 1980s, when several forces pushed food companies toward HFCS at the same time. One force was sugar price spikes in the 1970s, which made regular sugar more painful for manufacturers buying huge amounts. Another force was American sugar policy, including quotas and tariffs that helped keep domestic sugar relatively expensive in the United States. At the same time, American corn remained abundant, and high-fructose corn syrup fit perfectly into a country already built around massive corn production. HFCS also had a practical advantage that sounds boring but mattered enormously in factories. It was sold as a liquid. That liquid form helped beverage bottlers and large food companies because it mixed easily and moved neatly through industrial equipment. Liquid sweetener could be stored efficiently, pumped directly through factory systems, and measured with highly uniform sweetness from batch to batch. For industrial food makers, those details are not tiny conveniences. They shape cost, speed, consistency, and large-scale production planning. This is why the soft drink industry became the decisive battlefield in the rise of high-fructose corn syrup. By the 1980s, major American soda makers had largely switched from cane sugar to HFCS for most of their domestic production. That change mattered because soft drinks were already one of the biggest sources of added sugar calories in the American diet. Once soda shifted, HFCS moved from being a chemical success to being a daily presence in millions of American meals and snacks. After soft drinks, the sweetener spread across the pantry into bread, buns, cereals, ketchup, barbecue sauce, salad dressing, yogurt, and jams. It also entered baked goods, desserts, and many shelf-stable processed foods, especially products that benefited from cheap, easy liquid sweetness. That spread changed not only what Americans drank, but also how sweetness entered foods that were not always seen as obviously sweet. A sandwich bun, a bottle of dressing, or a jar of sauce could now carry corn-based sweetness made practical by industrial chemistry. Per capita use in the United States rose dramatically from almost zero in the late 1960s to a huge peak decades later. A commonly cited industry figure puts the peak at about 8 pounds per person in 1999, which shows the extraordinary scale. That number does not mean each person literally swallowed 8 pounds, because it measures deliveries into the food supply, not exact intake. Even with that warning, the number still reveals how thoroughly high-fructose corn syrup entered the American food economy by the end of the century. For a time, HFCS nearly rivaled sugar itself in American use as a caloric sweetener, which would have sounded impossible in 1957. So did Marshall and Kooi alone change what America eats? The honest answer is no, but they did start the chain. Their enzyme-based conversion of glucose into fructose gave industry a new path for turning abundant corn into abundant sweetness. Then later engineers improved that path, and then manufacturers, farm policy, and price pressures pushed that sweetness into everyday products. That three-part story is much better than a simple villain story about one ingredient suddenly appearing out of nowhere. Act 1 is the scientific breakthrough, when Marshall and Kooi published their discovery in 1957 and secured a patent in 1960. Act 2 is industrial scaling, when Japanese researchers and engineers improved the enzyme technology during the 1960s. Act 3 is full adoption, when American food makers embraced HFCS during the 1970s and 1980s because the economics looked irresistible. The economics mattered because cheap sweeteners shape more than price tags. They shape recipes, product design, and the background taste of a culture. When sweetness becomes easy, stable, and cheap, companies can add it to more products without the same cost pressure from regular sugar. That does not mean every company made the same decision for the same reason, but the overall direction became clear. Soft drinks led the way, and, after that, processed foods followed, turning HFCS into a normal ingredient across North America. There is a hidden irony in this history. Marshall and Kooi were doing applied chemistry, not trying to trigger a public health war. They were solving a technical problem in a nation where agricultural surplus, food science, and mass manufacturing already worked closely together. The United States grew enormous amounts of corn, and their discovery helped show how corn could be turned into sweeter syrup on purpose. Once that became industrially practical, the sweetener fit a 20th century American pattern of scaling farm products through food technology. That is why the story is bigger than two researchers, even though the researchers still matter at the beginning. The full chain includes patent holders, Japanese process engineers, corn refiners, beverage executives, and the trade rules affecting sugar prices. It also includes consumer habits, because a cheap sweetener changes the market only when millions of people keep buying the finished products. By the late 20th century, that is exactly what had happened. HFCS sat inside drinks, snacks, sauces, and many packaged foods. Then the story changed again, and this is when high-fructose corn syrup stopped being only an ingredient and became a symbol. In 2004, A widely discussed commentary by George Bray and Barry Popkin drew attention to the parallel rise of HFCS and obesity. That article did not prove that HFCS caused obesity all by itself, but it changed the public conversation in a major way. After that, high-fructose corn syrup became a cultural villain in the United States, especially in debates about processed food and weight gain. Critics argued that fructose-heavy sweeteners might uniquely promote fatty liver, higher triglycerides, insulin resistance, and overeating. Defenders replied that HFCS and sucrose are metabolically similar enough that blaming one while ignoring total added sugar misses the larger issue. That larger issue is excess added sugar and excess calories overall, especially when the sugar comes through soft drinks. Sugary drinks matter so much because liquid calories can be consumed very quickly and in very large amounts without much fullness. Over time, the scientific debate became more nuanced than the loudest headlines and internet arguments first suggested. A broad mainstream view developed that very high intake of added sugars is clearly linked with harmful health outcomes. That warning applies strongly to sugary drinks, which helped make soda a central part of the health argument around HFCS. But the evidence that HFCS is uniquely more harmful than sucrose under matched calorie conditions is much weaker than many popular claims suggest. In simple terms, the strongest scientific case is against too much added sugar in general, not only against HFCS as a special poison. Even so, high-fructose corn syrup kept its role as a cultural villain because it represented something bigger than a chemical formula. It came to symbolize industrial reformulation, cheap calories, and the changing of ordinary foods into highly rewarding processed products. That symbolic power helps explain why public anger often focused on HFCS even when scientists gave more careful and mixed explanations. The politics around the sweetener became fierce, and the corn refining industry spent heavily trying to defend its product in public. At one point, the industry tried to rebrand high-fructose corn syrup with the friendlier name corn sugar. Regulators rejected that change, which shows that even the words used for the sweetener had become part of the fight. The corn industry and the sugar industry battled each other in advertising and in court, turning sweetener choice into open commercial warfare. International trade also shaped the story, especially in the United States and Mexico, where sweetener policy affected bottlers and manufacturers. That detail matters because ingredients do not rise only because of taste. They rise through pricing, law, trade, and factory convenience. High-fructose corn syrup won in America partly because corn was abundant and sugar policy made regular sugar relatively expensive. Its liquid form also made it useful in industrial systems, especially when beverage companies wanted reliable, uniform sweetness at scale. Those factory advantages are easy to overlook, but they help explain why soda companies switched so decisively in the 1980s. If you run huge bottling operations, a liquid sweetener that mixes easily and pumps directly through equipment is a major advantage. That practical convenience helped push HFCS from chemistry journals into vending machines, fast food cups, and supermarket shelves. The backlash grew anyway, and by the late 2000s and 2010s, consumption in the United States began to fall. Many manufacturers reformulated products to use sugar again because consumers viewed sugar as more natural and less industrial. That shift was pushed by clean label marketing, anti-sugar campaigns, beverage taxes, and changing public taste. Industry data from the late 2010s placed per capita HFCS deliveries around the mid-30-pound range, far below the 1999 peak. That decline is significant, but it does not mean HFCS disappeared from American food or from North American manufacturing. It remained one of the most widely used caloric sweeteners in North America even after the public backlash had become strong. That is another reason the story lasts. High-fructose corn syrup shaped the food system so deeply that it could not simply vanish overnight. Its rise changed recipes, supply chains, bottling habits, and the economics of processed foods across several decades. Its decline shows something else. Consumer perception can push companies back toward sugar even when the chemistry debate stays complicated. So when people say HFCS changed what America eats, what exactly changed? First, the source of sweetness changed in many products. Instead of depending mainly on cane sugar or beet sugar, many manufacturers turned to corn-based sweetness made practical by enzyme technology. Second, the scale of sweetener use changed because HFCS fit large industrial systems so efficiently. Third, the spread of sweetness changed because HFCS moved into many packaged foods beyond obvious sweets and desserts. Bread, buns, cereals, ketchup, barbecue sauce, salad dressing, yogurt, jams, and baked goods all became part of the new landscape. That does not mean HFCS alone created processed food culture, but it became one of its strongest and most recognizable ingredients. There is also a hidden lesson about how modern food systems work. The winning ingredient is not always the most beloved ingredient. Often it is the ingredient that is abundant, cost-effective, easy to transport, easy to store, and easy to run through machines. HFCS checked many of those boxes in the United States during the 1970s and 1980s. That fit between agricultural surplus and industrial convenience is the real reason the sweetener became so powerful so quickly. It helps explain why two researchers making a 1957 discovery could indirectly reshape pantry shelves decades later. Marshall and Kooi did not personally put HFCS into soda, bread, or salad dressing, but their work made that future possible. Without their enzyme pathway, later engineers would not have had the same starting point for commercial scaling. Without large-scale scaling, soda bottlers would not have had the same reason to switch away from cane sugar. Without that switch, HFCS might never have become such a giant part of American sweetener history. That is why the story works best when told with several actors instead of one magical inventor. Marshall and Kooi gave the first crucial answer. Japanese engineers improved the process. American industry supplied the demand and the distribution. Farm policy, sugar tariffs, and price spikes then helped decide when the new sweetener looked better than the old one. The national diet changed because science, engineering, economics, and policy all pointed in the same direction for a time. Then public opinion pushed back, and the same ingredient that once looked efficient began to look suspicious and overly industrial. That backlash did not erase the chemistry. HFCS 55 still remained compositionally close in broad terms to sucrose. HFCS 42 still remained useful in processed foods, and HFCS 90 still remained important as an intermediate blend stock. But the public meaning changed, and meaning matters in food just as much as manufacturing costs do. Sugar started to seem more natural to consumers, even though both sugar and HFCS deliver large amounts of sweetness and calories. That shift in feeling helped companies reformulate products, which shows that culture can redirect industry after industry has already scaled up. Still, the late 20th century surge remains one of the clearest examples of how one ingredient can remake eating habits. From almost zero use in the late 1960s to about 63, 8 pounds per person in 1999 is not a small trend. It is a sign of a food system that discovered a new tool and then used that tool almost everywhere it could. The phrase "changed what America eats" is dramatic, but the evidence shows real change in drinks, sauces, breads, and processed foods. And the phrase "invented by one man" is dramatic too, but history gives us two names at the start, not one. Richard O. Marshall and Earl R. Kooi deserve credit for the core scientific breakthrough reported in 1957. Japanese researchers and engineers deserve credit for making the process commercially viable during the 1960s. Food companies deserve attention for pushing the ingredient into soda and many other products during the 1970s and 1980s. Public health writers deserve attention for helping turn HFCS into a major topic after 2004. Consumers deserve attention too, because their fears and preferences helped drive reformulation in the late 2000s and 2010s. So the most accurate version of the story is not one man changed America with one invention. The most accurate version is that two mid-century researchers opened a scientific door, and an entire industrial system rushed through it. That system included corn abundance, sugar policy, factory design, beverage strategy, and a culture increasingly filled with processed foods. The result sat in soda fountains, supermarket aisles, lunch trays, and kitchen pantries across the United States for decades. Even now, the story still matters because it shows how hard it is to separate chemistry from economics and public health. One enzyme-driven discovery helped turn corn into cheap sweetness, and that cheap sweetness helped shape the taste of a nation. It also helped shape a political argument about obesity, processed food, and whether modern diets are engineered for overconsumption. That is why high-fructose corn syrup still gets such strong reactions long after its peak has passed. People are arguing about more than fructose percentages. They are arguing about trust in the industrial food system itself. Marshall and Kooi did not set out to become symbols in that larger fight, but history placed them at the beginning of it. Their work was applied chemistry, yet its consequences spread through trade policy, bottling lines, advertising, and public health debate. That long chain is what makes this story so powerful. A technical solution inside a company lab became a national food transformation. If you want the next piece of that transformation, watch our next video on how sugar policy and soda economics rewired the American diet.